Assalamualaikum and greetings to everyone. My name is Mohamad Hadif bin Badrul Hisham and my supervisor is Dr. Mohamad Azizi bin Abdul Rahman. Today I will be presenting on the design and build dual axis solar tracking system. Without further ado, let's continue to the introduction. So basically, as we all know, Malaysia is a very hot country because of our geographic location at the middle of Khatulistiwa. And because of that, we only have 2 seasons, which is sunny and rainy, but mostly the weather is sunny throughout the whole year. As for the weather in Malaysia, the most suitable renewable energy sources is solar system. But what is the problem with fixed solar panel? In Malaysia, the most commonly used system is fixed solar panel, where it stays only in one direction. When the sun is moving from east to west, it cannot track the sun. Thus, it can only harness the highest amount of energy on the afternoon, where the sun is directly perpendicular at the modules and is at the middle of it. And basically, when this happens, the temperature of the solar panel will rises and the efficiency of the solar panel will drop. Because of there's no rotation, especially at the evening, it will result in loss of energy. So that's where the solar tracker comes. It can track the sun and directs the solar panel towards the sun and able to get the maximum energy from the sun. There are 2 types of solar trackers, single axis and also dual axis solar tracker. So why dual axis tracking system for this project? Here are some factors. First is able to generate more energy by 10 to 20% or higher depending on the geographic location and time. Second is able to generate huge amount of energy throughout the day because of its ability to track the sun. And third one is because of its dual axis, it's able to rotate more freely to track the sun's movement and capture more sunlight. So aim of this project first is to design a dual axis solar tracking system prototype with IoT monitoring. Second one is to study the effect of dual axis solar tracking system located at a spacious area without any disturbance. Third one, to analyze the performance of the designed solar PV with tracking system in harvesting energy. So based on this table, with the using of tracker, the energy received and density received of single axis and double axis increase significantly when comparing to the fixed panel. Here is the comparison of fixed single axis and dual axis on the setup cost to the energy capture. The setup cost of the single axis and fixed is cheap, while the dual axis is the most expensive. For the mechanism of the dual axis is the most complicated. While the measuring movement of dual axis, it has vertical and horizontal. The single axis has vertical only, and fixed panel has no movement. This results in high efficiency of dual axis system and single axis system. The energy capture by dual axis is the most highest, while the fixed solar panel is the lowest. So for the system design functionality, with the solar panel and the LDR sensor on top of the solar panel to detect the sunlight and send the information to Arduino. And then it will send the signal to motor driver to rotate the motor 1 or motor 2 based on the sunlight. Then the solar panel will charge the battery, which is the power supply for Arduino or Raspberry Pi. And we also have IoT monitoring for the current and temperature monitor. Here is the design of dual axis tracking system. We have 2 actuator motor for tilting and panning of the solar panel. We have a control box at the base of the solar tracking system for electronic components. So for the future works, this study will continue to design the final draft of the solar tracker based on real-time observation of the places, materials and any other factors. The second one is building the prototype at a spacious area located in Bangi. Third one is for the material selection to find suitable materials for building the dual axis solar tracker. And last one is testing for functionality, doing testing and calibration for all electronic parts and circuits. So that's all from me on the dual axis solar tracking system. Thank you.